Alright, welcome our users. This is Professor Scott going through the Chapter 3 exercise on the hands-on data science for digital marketing or for marketing. I'm going to go through today's exercise is focused on logistics regression, which is sort of guessing at the influence of different variables on whether or not a customer or your audience will engage with your marketing material. So I have kind of before me the open RStudio IDE. I have the Chapter 2 open as well because we might be better off to look back through there and see if we reuse any code or if any code has changed significantly. It's always a best practice to keep and to save those old codes that you use because you can always just adapt them to new data sets. Okay, and I'll give you one example here. In this one, the same sort of as integer is just not going to work when we're coding that one variable for engaged for this exercise, and it's going to mess up everything else that's past that for this exercise because it's all based on that one variable column right there. So we'll start from the beginning and then we'll get there when we get there. All right. So last time you installed some packages on your RStudio. So now, like with that example with going to the tool bench, you've already bought that tool. Now you just need to bring it to your workbench. So that's what you load the library for. I always like to have tidyverse instead of just dplyr by itself. The tidyverse brings in a whole bunch of other things, even ggplot2 is being one of them. So you can either run these two library here, or you can just run the library of tidyverse, and the tidyverse contains all of those things, and it'll give you little messages saying it's done or whatever. On the tidyverse, it'll kind of show you that there's a few codes that are masked or prevented from running when you're using other packages that are in tidyverse, and those warning signs and those things are normal. It's going to do what you needed to do, especially for this exercise, and then in most cases the tidyverse is just about all you need. The things that overlap, there's functions that do the same things in different packages, and that's the message that it's showing you there. Now we're going to load in our data set. So right here, just to walk through that, I have my data set name, and I'm calling it df for data frame. And then I'm calling read.csv, so that's comma separated. And this file name here is that Washington Financial use, marketing customer value analysis. Header equals true means I'm keeping that header variable name row. That's going to become my names for all of the different columns that are going forward, and then this is the separated by comma. With RStudio, you also know that you can go down to the bottom and do that import data set. And with a CSV, it's not an Excel, so you're going to use a text. And you can either use, this is going to be base R or a package reader. I usually use the reader. I don't think there's too much of a difference, but then it'll pop up on your browser screen to go and get it, and then you find your same file, open it up there, bring it in the preview, and then you have to make sure that you go down here and you give it the name that we're going to be using, and that again is df. So there's two ways to do that, and it looks like I didn't get it saved under df, so we're all right there. I'm just going to use df as I already loaded up from my code. So now step one, we're going to create that engaged column variable. So that's what this is doing here. We're calling up our data frame. That little money sign is going from data frame to column or to variable. Right here, we don't have this engaged yet, so this is what we're actually creating at this time. And then in his original code from the course textbook example, he says as integer this row, and which normally or in past R versions it would have given us a 1 and a 2, and then you subtract 1, and that's how we would have gotten 1 and 0. But that's not going to work, so we need to use this if-else statement that I showed you in the chapter 2 example. And so we say if-else that data frame, that variable response equals yes, then it's going to be a 1. If not, or if else, then it's going to be a 0. So as we run that, we create that new variable. So compared to our original data set, this one here has 25 variables. We can look at that in RStudio if we want to. We can pull it up and drag all the way to the other side, and we can see our engaged variable now is created, and we have some zeros and some ones. If I look at that 1, it should correspond to a yes response in that column there. Alright, now we're off. So a few things that we've already done before, I'm just going to show you again so that we can get them into our system, because we'll be using them for some of the exploratory data analysis, which is what's happening first here. Just looking at engagement by different categories. That's what we're doing here. We're using these pipes. They come from the dplyr package. If you've loaded your library dplyr correctly, then you'll have that pipe. So what we're doing, we're calling a new data set or a new data frame. We're calling it engagement rate. We're taking our existing data set, that DF, which is all of our data set here from the CSV file that we loaded up for that campaign. We're piping it through to group by engaged, which engaged was that new variable that created of ones and zeros that correspond to whether or not that customer engaged or responded to our email. In this case, I think is what this data set is. So we're taking the data set, we're grouping it by engaged, then we're running it through the pipe, and we're going to summarize, and we're calling this new variable that we're summarizing count, and then we're calling the command for count, which is in parentheses, and then we're going to run that through a pipe, and mutate is actually how we create a new variable. And so we're calling this new variable, or new calculation really, percentage, and then we're calling in that new variable column that we created here with count, and then we're going for the number of rows in our data frame, and then we're multiplying that by 100. So we're basically getting a percentage of, right, those that had 0, those that had 1s, and we're putting that into a data frame. So then when we print that out, just by running over the name of the data frame, we're looking at the engaged, the 0 and 1 were the options. We have that total count, 7826 and 1308. That's going to add up to 9134 observations there. And then this is the percentage of the total data set that we calculated by looking at the total count and then the number of rows multiplied by 100. And then in the textbook, he thinks that this is a little unclear, so maybe if we transpose it, this is the transposed view of it. That's what he's creating with this. This is the R command for transpose. That's a base R command. You can just flip. It's going to flip rows and columns, just like in Excel. If you're used to that transposed category, if you copy and paste different tables, you can mix up the rows and the columns as needed. And then he does a few things to kind of make it more presentable. This right here, he is actually calling the column names something different. We're going to call them the engagement rate engaged. So this is going to be zeros and ones here. And then transpose, he's taking away that first column that is kind of meaningless. And that's what we get. So there's the total count, which is going to be 7826 for the zeros, 85.7% basically did not engage. Then the count for those that did engage, 1308, and then 14.3%. So only about less than 14.5% actually engaged with our email marketing in this case. Now we're going through and we're going to look at the renewal offer type. So we're calling our new data frame, our new data set renewal offer type. Again, we're taking our original data set data frame and we're piping it through using the pipes from the dplyr package or from the tidyverse package, however you want to look at it that. Then we're actually grouping by two different variables. So we're grouping by engaged, which is our created zeros and ones from the responses. And then this other variable, renew offer type, which if we go back and look at our original data set, renew offer type is going to be one of these at the top. And as we look at that, we can kind of see that there's 1 through 4 on the offer. And that's what this little variable is doing. So we're grouping by this engaged column and then by this renewal offer type column. And then we're just giving a simple count. So how many fit in each of those groupings of categories. Okay, so we have a little bit of a warning message, and what it's telling us is that the summarized package has grouped it by engaged. So engaged is going to be first when we look at this data set. So now we've called it in so we can look at this data frame. And what it's showing you here is the engaged, the type, because that's what we renamed it when we said type equals renew offer type, and then our count there. So for non-engaged, these different offers, these were the counts for those different offers. For those that did engage, so right off the bat, we might have an actual business insight, right? None of those for offer 4 were engaged. So all of those emails that had that 4th offer, whatever it was not accepted by anyone. Right, next we go into pie charts, kind of looking at these data frames in a different way, just so that we can get a visualization of that. In my opinion, this is kind of a clunky graph with even some misspellings. That's okay. We'll fix that up there. When you get into that with ggplot2 and you get into the syntax of all that, you can make these things a lot prettier, and especially pie charts are a little difficult to get cleaned up because they still rely so much on the geometry of getting that circle right. Anyway, moving on here, so we kind of see that the percentage there of the 0 and the 1 of those that accepted, and then that, again, that offer 4 is not in that pie chart for the accepted. Next, we're creating a sales channel. So we're doing basically the same thing with that last data frame, except now we're looking at sales channel. So sales channel might be a type of outreach, or yeah. So I guess that would be like the medium of outreach. Maybe it came through the call center, they came through the web, or it came through an agent, or at the branch. So we're working with a bank, and there's a couple different ways where we try to get these offers out to our clients, and now we've marked them as a variable sales channel. So we're going to pull that same, and then it's telling us again that it's grouped it by engaged and given us the count for those different variables. When we look at that, we see again, so engaged 0 and then 1, and then we can look that now we have some accepted through that web. So we didn't have for offer 4 in the last one. It looks like each of these different methods had both non-engaged and engaged clients. And now we can look at a visualization of that and see sales channel, the 0 and the 1s. And then visually looking at this, you can see that those rejected are more equal slices, but it looks like the agent is way more effective. The agent and the branch are way more effective for those that engaged with the different offers. So that could tell us something, right? Our agents are well trained, or they can apply enough social pressure. Maybe they have a relationship with these clients, and so they're engaging with that offer a lot better than they are on the web. So all of this is EDA, just exploratory data analysis, looking at different combinations. Might be based on some theory, or to check up on specific questions like which method or which sales channel is giving us the best engagement rate. Here's some more visualizations doing a few different things. These are going to be box plots. This one is looking at total claim amount. Or these both are looking at total claim amount, excuse me. One is showing you the outliers, and then one is skipping that view of the outliers and more giving you a smooth graph there, focused mainly on the averages and the quintiles. Now we switch over to income and give us a box plot for income of those that engaged and did not engage again. And now we have a breakdown of summary statistics. So now we're wanting to get really involved with income and see the breakdown of our clientele. And so what we're doing here is we are creating a data set. So again, we're naming it income description. This is our equal sign for our new data set. So we're saying this is what's going to be the result of everything that we call after this. We have our original data frame, our data set there from the bank and the marketing. We're piping that through and grouping it by that variable that we created of engaged. So there's going to be a 0 or a 1. We're piping that through again to summarize, which is a call to do a lot of different calculations. Now we're going to utilize just a few of those. So what we're saying here is min is going to be the minimum for that variable income. We're calling Q1 is going to be a quintile for income at 0.25. Then we have the median income. Quarter 3, we're calling quintile again on income. This time we want that upper range, 0.75, and then max, there's the max call. We can do this here, and there we go. And then I think I was playing with this, so that maybe you can do it the same way. This gives you a lot more information and kind of blows it up. This one is nice and simple. Shows that here we have the min, which is both zeros, that quarter 1 for those engaged, quarter 3, max, and then that median income. So the median income doesn't seem to be too far apart for those that engaged and those that didn't. Now, a few other ways to do summary statistics. You can do this per column. This is going to blow up just like that last one did. So we're looking at one call. That's a very simple line that's in base R, that summary of the data frame, DF. But we can look at each variable here that's listed, and when it's a numerical value, we'll be able to see the minimum, the median, and the maximum and the mean right here in our console. So Customer and state, those are actually character variables, so that means there's strings, there's writing there, there's not numbers that can be analyzed in that way. But customer lifetime value is a numeric, and so we can see a minimum, a first quarter, a median, a mean, and all of that. So you can look and see which variables are numeric values and then which ones are character or writing variables in this way. And then one piece of advice, he says to get the data types for each of the columns. This right here is one way to run that code and to do that. But to me, it's not super clear. And in base R, there's a pretty easy call. Just structure is what these three little words, or what these three letters represent. And it gives you a much sort of cleaner presentation of the structure of the variable. So this one we have number, you have integer, and number and integer are basically interchangeable for us at this point. There's a few things that integer can do that number can't do, and that's just dealing with decimals and scientific notation. But for our purposes here, integer and number are the same. Okay, so moving down now, we're setting up for our logistic regression. And when we're thinking about the logistic regression, we really want to focus on the whole data set, but sometimes it's easier to just look at the numerical values. And so that's what we're setting up here in this first example, and then we're going to build up to using the whole data set. So what he's creating here is the continuous DF. So he's saying we're getting all of those numerical values or integer values into one data set, and we're going to run that in a logistic model. So this is the name of our new continuous data frame, or continuous DF, and he's running the code select if within this data set that value is numeric. And so this is numeric should pick up those variables or columns within that data frame that are both numeric and integer. So we can run this, and then we can give them the column names. And this is a call to just see which variables we were left with. So we got customer lifetime value, that was a number there. We have income, that was a number there, or integer. Then we have monthly premium auto, so we have each of these in that data set. And then when we look down into our data environment here, we can click on that continuous DF and we can actually look at this separate data frame within our studio. So we've got all of these numeric values right here by themselves. Okay, now we're actually going to fit and run our first logistic model. So we're calling our first logistic model logit fit. That's just the name. How are we fitting this data set with a logistic regression? That's kind of the shorthand that's happening there. The call for a logistic regression is GLM. And engaged is actually going to be our dependent variable, because that's the one that we're trying to predict with our input variables. Okay, so we're wanting to see how these different variables influence our created variable of engaged. So these different things like the income of a client or the gender of a client have some sort of impact on the likelihood of them opening that email or accepting that offer, right? Logistic regression is a way to try to determine the weight of influence that each of those variables has on the likelihood of that customer accepting that offer. That's more or less what we're trying to do with logistic regression. But to walk through what this is actually telling us in the code, we have our dependent variable, which is engaged. this little squiggle here shows that we're now going to independent variables, or we're regressing this variable by these other variables. And this is a shorthand in R for all variables, that period there. And then the next clause in this parenthetical statement, we're calling our data set. And so right now we're calling this continuous data frame. And so all of these variables that fall in this, actually we're just calling on this whole data set. So we're transgressing, engaged, and we're calling the data from this one data set here. And then binomial is a description of our independent variable. So it's either a 0 or a 1. Binomial there. So I'm running this, and then to actually see the output or the printout of what that logistic regression did, we're going to say summary logit fit. So we're calling in that logistics regression that we just ran here, and we're asking for the summary. And so this is our summary, and he kind of walks through a little bit on how to read that. I was trained in a different way on how to read that, but for our purposes here, we're just going for general direction of influence and whether or not that influence was statistically significant. And what we mean by statistically significant, if we look down here at the significance codes, you can kind of see some of these different markers are going to be right beside these variables up top here. And what this is basically saying is that when we take a sample of a whole population and we run our regression or our statistical model on this, we're saying that a percentage chance that this does not represent the whole population. And the significance level is showing you how confident we are that this sample represents that whole population. So if we have a 0, that means 0.000001 or something like that, that means that we can be 99.9% sure that if we were to make 1,000 samples of this population, that they would look like our statistical model. 0.001 is literally 99.9% confidence. 0.01 would be 99% confident. 0.05 would be 95% confident that if we took 1,000 samples of this population, our regression model would sort of be the same. It would reflect that full population. 0.1 is 90% confident, and you can kind of go down from there. Within the academic world, we're often looking for at least 0.05 of confidence. In the business world, decisions can be made at a lot less, right? If you can be 75% sure that your sample represents the whole population, then you might be able to speak to that. It's always important to understand what you're reporting when you're going to report something like that and say that this might not be completely representative of the whole population, but we think that our sample is representative, maybe based on theory or some other understanding of what's going on with the different variables and what they mean in our statistical model. So looking at this here, we have the intercept, which basically means that the regression itself has some statistical significance, but the individual variables only look they have at the 0.1 statistical significance level. So that means we can be about 90% confident that our sampling of this population would be representative of that whole population. And generally our Z values are positive. So as income increases, we can look at this and we can see that there is a greater chance. So it's a positive, so it's a greater chance of someone engaging with our offer. So that's kind of how you would interpret that. Number of policies is interesting. So it is statistically significant at the 90% level, but it's also negative. So there is, with the increase in the number of policies, we actually have a lower likelihood of being engaged for an offer from that client. I hope that's making sense as I'm saying it. Again, to this last one, so total claim amount. So as the total claim amount increases, we have an increased chance of that client engaging with a particular offer. All right, so moving down here, now we're starting to incorporate those categorical variables, which if you go back and look at that opening chapter that I posted in the first module, looking at those different types of variables, a categorical variable is something that has kind of different options or different ranks, but they're not always ranked and they're not always meaningfully aligned. So we can say like male, female. That is a categorical variable. You can fall within the category of male or female. Education is also a categorical variable, but it can be ranked. So you can have a higher education achievement, but it's not necessarily in a numeric of 1, 2, 3, 4, 5 education. So here we're calling another logistic regression. We're going to give it that same name because why change it if it fits here? We're calling in logistic regression with that GLM. This is our independent variable, or our dependent variable, excuse me, and we're regressing on. For this one, it looks like we're just using this one variable, education, and we're telling it to become a factor. So really what's that telling R to do is to treat education. There's about 5 different levels of education, and it's going to just assign a number, a distinct number to that. And then we're using our data, and it's going to equal that original data frame because, again, in our continuous data frame, we didn't take the variable education. We just took those numerical ones. So we need to go back to our original data set here. And then again, that family is binomial. So we're going to run that here and then look for that summary of the logit Oh, that's how it does it here in R. Lest I forget. Okay, so what that did for the factor in R is it actually split it out so that it looked at these individual variables and then it decided whether or not that had an impact on engagement. So factor education, that's our column name. The option is college, and then how that had a relationship or did it influence whether or not that client engaged our offer. It looks like for here, the only 2 variables are the doctorate and the master degree. As you can see there with that little dot, so it's at the 90 percentile of confidence. So we're not too confident in that, but we're about 90% confident that our sampling would represent the population. And they're both positive. So as this is reached, we have an increased likelihood of that client engaging our offer. So this looks like something that more education would actually make someone more likely to engage. Now we're doing the same thing, but for both of our categorical variables in the data set of education and income, or sorry, education and gender. So again, we're calling that same name logistic regression. We're running a logistic regression here with this code. This is our dependent variable regressed over our independent variables, which for this model, we're including the factor of education. So we're going to have these same breakdowns. And then gender here, which is going to be male and female in this data set. Our data set is that original data frame. And then again, that binomial is that 0 to 1 for our dependent variable of engaged. And we'll run the summary. And so right here, One thing that you can kind of see with this printout is that just male is represented here. So that male, when we did the factoring, male was kind of assigned to that one variable. So female would be 0 and male would be 1 in this understanding of factoring. So as we move towards male, which would be that 1, right, then it would, if this was a statistically significant relationship, it would increase our likelihood of receiving our offer or accepting our offer. But this is not a statistically significant variable on whether they'll engage with our offer, and so we don't really need to interpret that. What we can interpret again is the master's level and the doctorate level, and so this is still significant even when including gender in there. All right, so now we're getting out to the bottom of the example and the last two things in our last logistic regression. So now what we're doing is we're adding the continuous and categorical variables to one data set. But we're adding the factored version of both gender and education. So we're adding it here as gender. So what we're doing, we're calling that data frame of the continuous DF, which was again just our numerical values. And we're calling a new variable gender. And then we're going to add the factor version from our original data set, the column gender. So that's what we're doing here. Going to run that. And then we're creating a new column in that continuous data frame again called education, and we're using the factored version of data frame, that original one, DF, row or column education. So now we can look at this and you can kind of see the breakdown that we added here at the end. So now these are going to be factors, and we can use them in our regression where we're going to look at engaged again, all in one logistics model. So now we have logifit again, that same logistics name. We're calling it. Engaged is our dependent variable. We're regressing it. That's what this little squiggle means on all data points. That's what that period means in the first clause. We're calling in the data, the continuous data frame that we just built up by adding our categorical variables to. And then we're again calling that binomial because our dependent variable is 0 and 1. And then we're going to call the summary on that and look at it. So we've got our printout here. And we've got two variables that have now hit the 95% confidence level. Or excuse me, they're at the 99% confidence level. All right. So we have total claim amount, and we have the doctorate in education and still the master's in education. So those still have remained a positive influence on that. Total claim amount, if we recall from the original continuous data frame from that logistic model, that was also a statistically significant. Number of policies was statistically significant with our little period there, but it was a negative. So the more policies you have with the bank already, you're less likely to receive another offer. That kind of makes intuitive sense there. If I already have enough policies, I'm not trying to take on more things with you all. And then income there. So as income increases, we still have a higher likelihood of accepting that offer. So this kind of shows you what we're doing when we're looking at a logistics regression model. So this has been the complete chapter 3 exercise for R from the hands-on textbook. Please let me know if you've used this video or if you have any more questions on how something should work out, or if you have some miserable typos that's ruining all of your code. We'll talk to you later.